Welcome back to my YouTube channel. So in this video we have given a probability mass function of the Poisson distribution and we need to find out the expected value and variance of this distribution. So first we're gonna find out the expected value of the Poisson distribution. So we know that it is a discrete distribution function. So the formula to find out the expected value of a discrete distribution is equal to sum of all x into p of x. Here px is simply this probability mass function. So now we're gonna put all these values here in this equation. So this is x and the range of x is from 0 to infinite, so it will be x equals to 0 to infinite into this probability mass function. So we have e to the power minus lambda to the power x divided by x factorial. Now we can write this lambda to the power x as lambda into lambda to the power x minus 1, and this x factorial can be written as x into x minus 1 factorial. So now our equation will be x equals to 0 to infinite x into e to the power minus lambda to the power x minus 1 divided by x into x minus 1 factorial. Now this x will get cancelled. So now we can take this lambda outside and this e to the power minus lambda also. Now inside this summation we have lambda to the power x minus 1 divided by x minus 1 factorial. Now here the value of x cannot be 0, so it will be from 1 to infinite. Now we have this equation, so we can write this as e to the lambda into e to the power minus lambda, and inside bracket if we put the value of x in this equation, so if we put x equal to 1, we're gonna get here lambda to the power 1 minus 1, so that will be 0 and that will be 1, and inside and in the denominator it will be 0 factorial and it will yield 1. Now if we put x equals to 2, so it will be lambda to the power 2 minus 1, that will be lambda to the power 1 divided by 1 factorial plus lambda square divided by 2 factorial plus dot dot dot, like this we're gonna get. So now this is lambda e to the power minus lambda, and we can see that this is in the form of e to the power x, because we know that e to the power x equal to 1 plus x square, but it divided by 2 factorial plus x cube divided by 3 factorial dot 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 till the infinity. So we can write it e to the power lambda. Now we can see that this and this will get cancelled, so we're gonna get lambda. So this is our expected value of the Poisson distribution, or you can say that the mean of the Poisson distribution. Here this lambda represents the average number of events that occur in the given interval. So this is also the same as the variance. Now I'm gonna show you how to calculate the variance of the Poisson distribution. So we know that the formula to find out the variance is simply v of x equal to expected value of x square minus expected value of x whole of square. So we have this expected value of x here, so we need to find out this value. So to find out this, first we're gonna write expected value of x square equals to sum x square into p of x equals to 0 to infinity. We can write this x square as x square equals to x plus x into x minus 1 in this form. So now we will have here x equals to 0 to infinity, and this will be written here x plus x into x minus 1 into p of x. Now if we open this, we're gonna get x equals to 0 to infinity, this x into p of x. First we go here, and then this will be x equals to 0 to infinity x into x minus 1 p of x. Now from our equation that we earlier calculated, we know that this will yield lambda, and from this we can write this as x from 0 to infinity x into x minus 1, and then the probability mass function, that is e to the power minus lambda to the power x divided by x factorial. Now coming back to it, it will be lambda plus this sum 0 to infinity into x minus 1 e to the power minus lambda, and we can write this lambda as lambda is square lambda to the power x minus 2, and this inside this x factorial can be written as x into x minus 1 into x minus 2 factorial. So now this and this will get cancelled, so we're gonna get lambda plus sum x 0 to infinity, then e to the power minus lambda square lambda to the power x minus 2 divided by x minus 2 factorial. And if we take this as common, so we're gonna get lambda plus e to the power minus lambda square, and then sum x 0 to infinity lambda to the power x minus 2 factorial. And now we can see that again this gonna yield us e to the power lambda. So we get lambda plus lambda square e to the power minus lambda into e to the power lambda, and this will get cancelled, so we will get lambda plus lambda square. Now we have this expected value of x square. So now we gonna get variance of x from this expected value of x square minus expected value of x whole square, and we have the value of this here, so it will be lambda plus lambda square minus the value of expected value of x is lambda and the whole square of it. So we gonna get lambda because this and this will get cancelled. So this is the variance of the Poisson distribution. So now we have the expected value, or you can say the mean of a Poisson distribution is lambda, and also the variance of the Poisson distribution is lambda. So we can say that for the Poisson distribution the mean and variance is same. So if you like this video, please subscribe my channel. Thank you.